All right, looking at the assignments, today is the 25th. We went over the test. We're going to look as much as we can today at Chapter 4, Levels 1 and 2. Notice that the first case problem is not due till this Sunday night, and the second case problem is not due till after class next Tuesday. So for sure, today and Thursday we could cover the first part and maybe even the second part. And if we look on Blackboard and look at the units of study, let's look at what you see. We should have Chapter 4. The first case problem, Level 1, is due Sunday night, just before midnight. And then case problem Level 2 is due next Tuesday night after class before midnight. And then here is what those case problems should look like. This says, here's the spreadsheet, and that's what it should look like after you do all the formulas. Doesn't tell you the formulas, but at least you know what it should look like. And same thing for Level 2. This would be one of the spreadsheets. I guess it's two sheets, so that would be one of them, and then the other would be the other sheet. And then notice also that I also included these things: customer credit and payment history level, rules 1, 2, and 3. So this is actually a spreadsheet that you can use as you go through the book. Let's make sure that is the one in the book. Athletic Gear Corporation. Is that Steps to Success, or is that the tutorial? I think that's the tutorial. Yes. So these allow you to work the tutorial and follow along in them. I'm thinking the best thing to do with the time we have today is to work through the Steps to Success, Level 1, because it's just like the tutorial prior to that. So page 241, Steps to Success, we're going to be looking at different rules, different functions we can use, and the file that we're going to use is PO 527. PO 527. Chapter 4, PO 527. I'm going to put that on the desktop, and I'm going to call it MESCO PO 527. That's not what they said to call it. They said to call it credit analysis. I guess I could add that. Here's the spreadsheet that we're going to be working on with these bidders, and we're going to be evaluating these bidders to see if they are worthy of our extending credit to them. But first of all, let's talk about some of the concepts. So I'm going to pull up a new sheet, and if we look at some of the ideas, I'm just going to skip through and hit the formulas. I'm on page 212 now. The first idea is logical operators, Boolean values. They're named after an English mathematician named George Boole. So a Boolean value is something that's one of two states, either true or false, or 1 or 0. And we can say equals 7, and it gives us 7. If I say, does 7 equal 7, it says that's true. So I'm making a statement, 7 equals 7, and it evaluates that as true or false. What if I said 7 greater than 7? Should that be true or false? 7 greater than 7. That should be false, shouldn't it? So if I press enter, it says that's false. So a Boolean value, as far as what we're thinking, is it's something that's either true or false. The second thing is talking about building formulas with relational operators. And remember, the relational operators are things that allow us to say that something is greater than or equal to or greater than or equal to. If you look on page 218, page 218 has a table of what those relational operators look like. I think we're all familiar with the equal, and we're all familiar with the greater than or less than. Ones that you might not be familiar with are to say that something is greater than or equal to. So if I say, is 7 greater than or equal to, it's the greater than followed by the equal sign. So is 7 greater than or equal to 7? Should that be true or false? That should be true, shouldn't it? Because it is equal to, greater than or equal to. So that's true. Same thing with less than. Is 7 less than or equal to 7? Yes, because it's equal to it. So that should be true. Is 7 strictly less than 7? No, that should be false. And then the one that you are almost certainly not familiar with is not equal to. Not equal to is the less than symbol followed immediately by the greater than symbol. So 7 not equal to 7, that should be false. And it is. But if I say 7 not equal to almost anything else, negative 14, that should be true, because those are not equal to each other. I'm wondering what would happen if I try to say, is 7 not equal to Mesco? It says that's true, because 7's not equal to Mesco. One's a number and one is text. But if you tried to divide 7 by Mesco, you'd probably get an error, because say, what are you talking about? If I said multiply 7 by Mesco, it says I can't multiply text times a number. Okay, so anyway, those are the relational operators. Back on 212, and, or, and not. I think we have talked about these a little bit before, but the way the and function works is, we've talked about what they mean. And means everything has to be true. We say equals and then we separate the things by commas that we want to check on. So I'm going to say 7 equals 7. That's one thing. And 4 is greater than 3. Are both those things true? 4 greater than 3, 7 equals 7. So if I say and, that's only going to show true if all of those things in the parentheses are true. So since both of those are true, that is true. Now what if I add a third thing? How about 6 is less than 5? Whoop. 6 is less than 5. That's not true, is it? So even though these two things are true, because I have and out here, it says, well, this one's not true. So that whole thing's not true, because they all have to be true. So this should be false, and it is. But what if I put or out here? Or says, as long as at least one of them's true, then the whole thing's true. So as soon as it sees that the first one is true, it doesn't even look at the other things, because it says, well, obviously that's going to be true. So I've got 2 true things and 1 false thing. This should be true, shouldn't it? So the or says, as long as at least one of them is correct. They could all be correct, but as long as at least one of them is, then the whole thing's correct. I'm sorry, the whole thing's true, as long as at least one of them is true. So and means they all have to be true. You could think of it this way. I just thought of this. And begins with A, doesn't it? And means all must be true. Or means at least 1 must be true. So we've got an O here, and we've got an O here, but it is at least. In other words, they could both be true and it would still be true. And with and, they've all got to be true. Typically, we only compare two things at a time, but we can list more than two things, and it'll take them two at a time, and then it'll take that and do it with the next one, and take that and do it with the next one. Okay, and then the other logical function is not. And not just means the opposite. So here's something that was true. If I put a not in front of it, that says whatever that thing in there is, take the opposite of it. So this should be false, since that or statement was true. Now I'm saying take the not of that, so that's false. Same thing here. This was false, 7 greater than 7. But if I say take the opposite of that thing, 7 greater than 7 is false, but not false is true. So this should be true. Okay, so that's how those operators work. Not just works on one thing. It says figure out if that thing's true or false, and now give me the opposite of it. Okay. Now that thing that was true or false could have a bunch of stuff in it. Questions or comments? Question is, when would you use not? Let's say we've got some letters, A, B, C, D. And if we say show me not that thing does not equal A, that's false, isn't it? Because it does equal A. So that should be false. But what if I didn't want it to be A, B, or C? Then I could say C3 I could say or C3 equals A, C3 equals B, C3 equals C. I say I don't want any of those to be true. Well, one of them's true, isn't it? Yeah, give me another. So that's false because I didn't want any of them to be true. But that's kind of awkward, isn't it? What if I said check to see if A and B and C are all true and take the not of that? So sometimes the not makes it a lot easier to write something. Instead of putting a whole bunch of stuff, you put the opposite of it and then you say not that. Okay? That's not, I didn't give a very good explanation on that, but that's often how not is used. What if we want to say show me all the stuff that is, show me if this number's between 60 and 80. Okay? Between 60 and 80. Well, there's a couple ways of doing it. We could say we want to know this number has to be less than 80, doesn't it? Or do we want 60 and 80 included? If we wanted them included, we'd say less than or equal to, or greater than or equal to. In other words, here's we've got 80 on top and we've got 60 on the bottom. If we want a number that's between those two, we'd say show me everything that's less than 80, which would include minus 7, and it also at the same time has to be greater than 60. So if you look on a number line where we would have a horizontal line and 60 and 80, 60 would be over here, and 80 would be over here, and 0 would be over here. Then we'd say everything greater than 80, everything greater than 60 is from here to the right, isn't it? So we could say all that stuff is greater than 60. And we'd say, what's less than 80? Everything less than 80 is everything to the left of this guy. So there's everything less than 80. And we'd say, where do they overlap? They overlap right here. So if we wanted to say, show me if this number's between 60 and 80, we'd say equals, it has to be both these things. This guy has to be less than or equal to 80, and at the same time, this guy has to be greater than or equal to 60. And it says that's true. It's greater than or equal to 60, and it's less than or equal to 80. And if I copy this formula down, it says, well, this thing's less than or equal to 80, but it's not greater than or equal to 60. So it's not between them. This thing is between them. This thing is less than or equal to 80. That part's true, but it's not greater than or equal to 60. Did that answer the question, Megan? That's how to show if something's between two values. All right, let's look at steps to success. I think we've gone over most of what we need to know to do that, or at least we've touched on it. And the steps to success is on page what? 241. And 241 is critical because it tells us some of the conditions. At the bottom of 241, it says, in these steps, you will help complete the credit analysis by applying the following set of rules. We want to say which of these bidders, they're bidding for a job and we're trying to figure out, they're bidding to borrow money, and we want to figure out if they are credit worthy. Rule 1 says, consider a bidder if its D and B, Dun & Bradstreet, if its D and B paydex is at least 90. So, if they've got a D and B paydex of at least 90, that means they're under consideration. Well, there's only one of those guys, isn't there? But look at rule number 2. It says, consider a bidder if all of the following criteria are met. First, their paydex, that same thing has to be at least 65. So there's only one person that doesn't qualify under rule 2 on that first part. Second thing is their composite credit has to be less than or equal to 2. So this same person fails on both of those. And the third one is the company's net worth has to be at least $500,000. And then there's a third rule and says if any of the following are met, that would be an or condition, wouldn't it? So rule number 1 is just one condition. Rule number 2 is 3 conditions that all have to be true. And rule number 3 is 2 conditions, only one of which has to be true, which would be an or. Page 242 now. We've opened the file, and it says, number 2, in column G, that's right here, calculate whether or not, true or false, the first company listed meets the criteria for Rule 1, place an appropriate heading, copy the formula down. What is Rule 1? Rule 1 is paydex score at least 90. What would that mean in terms of our relational operators? Greater than or equal to 90. Okay? So we'd want to write down what we're evaluating. So I'd say paydex at least 90, and I'm going to go ahead and format those the same as the other ones. Format painter, paint those other columns. So D&B paydex is over here, isn't it, in column E? So how would I write that condition? I'd say, is the thing in column E, that thing, greater than or equal to, which is the greater than sign followed immediately by the equal sign, is that at least 90? And that should tell me true or false. And they're all false when we copy that down except for one, right? There's only one that's greater than or equal to 90. That's that middle one. In column H, it says calculate whether or not the first company listed meets the criteria for Rule 2. Place an appropriate heading, copy this formula down. So what's Rule 2? It is paydex greater than 65. Is that the same as at least? No. At least includes the number, but greater than does not include the number. So let's write this down. We want to say paydex greater than 65. And what's the second rule? Or the second thing in the rule 2? Back on 241, the composite credit appraisal has to be less than or equal to 2. That's over here, isn't it? So I'm going to say CC appraisal less than or equal to 2. And of course we can spread this out so it'll be more readable, but I'm not going to worry about that. And the third thing that has to be true, all of these have to be true, don't they? The net worth has to be greater than $500,000. So net worth greater than $500,000. What kind of logical operator are we going to need to say that all three of these things have to be true? That would be and, wouldn't it? So I'm going to say equals and now notice it pops up and it says I need one or more logical operators, and we got 3 of them, don't we? So paydex, where's that? That's column F, right? No, I'm sorry, column E, my bad. Paydex is right here. That has to be greater than 65. Okay, that's the first criterion. Now what? Well, I have to put a comma. The second one is the composite credit appraisal has to be less than or equal to 2. And that's over here, isn't it, in column D. So that thing needs to be less than or equal to 2, comma. And now the third thing, their net worth, which is over here in column C, that has to be more than, greater than 500,000, $500,000. So that thing has to be greater than 500,000, no commas. Now, are all 3 of those things true of the first bidder? Is this greater than 65? Yep. Is this less than or equal to 2? Yep. Is this more than $500,000? Yes. For that first person, all 3 of those things are true. We copy that formula down, and I've got alternating true, false, true, false, true. Okay, let's look at the third thing, number 4. It says in column 1, calculate whether or not the first company listed meets the criteria for Rule 3. What is Rule 3? Back on 241. Stress risk has to be equal to 1, and previous grade is satisfactory. Stress risk class equals 1. And the second criterion, previous experience, is satisfactory. Now, do both of those have to be true, or just at least one of them be true? It says consider a bidder if any of those are met. Is that an and or an or? That's an or, isn't it? As long as at least one of them's met, then they're good. So this is going to be an or. Either the stress class risk is 1 or the previous experience. Either one of those will work. Now, of course, they could both be true, and that's fine, but if one of those is good, then they're good. The risk class is what column? F? That has to be equal to 1. If they got anything less than that, forget it. Equals 1, or either that thing's 1, comma, or this thing, column B, has to be satisfactory, and that has to be in double quotes because it's text. And we want to make sure we spell it correctly. We want to make sure it's spelled correctly over here. As long as one of them, at least one of them's true, then they're good to go. So it's true for the first person, isn't it? In fact, both of those were true. 1 and satisfactory. The second person, we got 2 and satisfactory. The 2 was not true, but the satisfactory was. Third person, 1 and satisfactory. The fourth person, so 1s make it true, satisfactories make it true. The only person who's false is this last one, because they don't have a 1 or a satisfactory. All right, so we've evaluated each of those 3 criteria, and now if we turn back to 241, it says we consider a bidder if any of these rules. Is it if any of the rules? If they meet any of the rules, or do they have to meet all of the rules? I think it's just any of the rules, isn't it? As long as they meet at least one of the rules, we're going to consider them. So the only person who we're not going to consider would be somebody who does not meet any of those rules. Let's look at number 5. It says in cell G9, that's down here. It says in cell G9, write a formula to determine if any of the bidders has a true value for rule 1. Copy the formula across to determine if any of the bidders has a true value for rule 2, and then do the same for rule 3. Enter an appropriate label for this row. Meets rule. And this was rule 1, wasn't it? Column G. I'm going to go ahead and say rule 1 for column G. I'm going to say rule 2 for column H, and rule 3 for column I. You don't have to say that, but I think it's a little, since we're saying it meets the rule, it'd be nice for people to know which rule are we talking about. All right. So, number 5 says, do any of the bidders have a true value? Well, what would that mean? We would be looking at these. What does any mean? Is that an and or an or? Any is an or, isn't it? As long as at least one of them is true. So we're going to say equals or. We don't have to say is G3 true. All we have to do is say is G3. In other words, yeah, G3 is G3. Let's try that. I could be wrong. So I think we can just say G3, G4, G5, comma, G6, comma, G7. It's looking at each one and saying, if that's true, give me a true. If it's not, give me a false. Let's see if that works. Yay! Now, the long way to do it would be G3 true, G4 equals true, G3 equals true is equivalent to equals G3. They think that's a formula, which I don't want it to be. If you want to write a formula but you want it to be treated as text, put an apostrophe at the beginning of it. Treats it as text and doesn't look at it as a formula. If we copy that over, it should say true for all of these, shouldn't it? Because at least one of those things above is true. So somebody meets every rule. There's no rule that everybody failed. That's number 5. In cell G10, write a formula to say none of the bidders has a true value. Meets the rule, or yeah, let's say someone meets the rule on this one. I'm going to right justify that so it spills left. And in G10, we're supposed to say no one meets the rule. Here's a good place for our not, isn't it? Number 6 says, write a formula to determine if none of them. So we could say equals not this, comma, not that, comma, not that, and put an and in front of it. But we've already got a formula that says this shows me if someone meets the rule. So to say no one meets the rule means this would be false. So all we have to do is say not that guy. Let's absolute value all these. Actually, we want to absolute the. Oh, shoot. Those trues are throwing me off. Let me get rid of those. We want the rows to be absolute, but not the columns. So it's going to stay between row 3 and row 7, but it'll copy the columns when I move it over. Copy it over. And notice it changed the column, but kept the rows. Changed the column, kept the rows. And now I'm going to copy this down. And I'm going to say, give me the not of that. Give me the not of that thing, because that thing says at least one person did it. And if I say I don't want anybody to do it, then that would be the opposite of all the ors. We'll do one that shows the long way to do it. This almost feels like cheating because we already know that's true and we know that's false. But here would be the long way to do it. Wait a minute, let me see what we need to do because we're running out of time a little. Oh, conditional formatting. Okay, I'm not going to mess with that today because that's a lot easier to understand than the formulas. Here would be the long way to say no one does it. We would say we want all these things to be true. We want not that thing. We want not that thing. We also want not that thing. Not, open paren, that thing. Not, open paren, that thing. Not, open paren, that thing. And not that. Oh, I put the comma inside the parens. I was wondering why that didn't light up. And not that thing. There's each not, and there's the close for the and. This says every one of those things has to be false. And that, what's that going to turn out to be? If every one of those things has to be false, is every one of those things false? No. So this statement will be false. So that's the long way to do what we did here. Thus endeth the lesson.